humans. We look up at the night sky and wonder, what's out there? Are we alone in this vast expanse? These questions have echoed through millennia, driving our quest for knowledge. This cosmic itch propels us forward, pushing the boundaries of what we know. It's written in our DNA, this urge to venture beyond the horizon, to explore the unknown. The universe beckons, and we find it hard to ignore its call, its mysteries. Every great leap in human history began with a question, a spark of curiosity that ignited our imagination. Space exploration is the grandest expression of this trait, a testament to our unyielding spirit. We send probes, telescopes, and eventually ourselves into the void not just for data, but to satisfy that need to see what's over the next celestial hill, to uncover the secrets of the cosmos. The allure of space is more than just scientific inquiry, it's about perspective, about understanding our place in the universe. When we see Earth from orbit, a tiny blue marble, it changes us profoundly. Borders vanish. Conflicts seem petty in the grand scheme of things. Space exploration isn't just about discovering new worlds, it's about rediscovering ourselves, our potential, and our unity. The quest to understand the universe pushes the boundaries of technology, inspires future generations, and helps us comprehend our own existence, our place in the cosmos. The stars are not just distant points of light, they are destinations, laboratories, and perhaps future homes for humanity. Let's talk about the X-37B orbital test vehicle. Picture a miniature space shuttle but with no crew on board. Operated by the United States Space Force, the X-37B is shrouded in mystery. Its primary mission is to test advanced space technologies. Think of it as a secret agent of innovation, quietly circling our planet. The X-37B launches vertically inside a rocket fairing, but lands horizontally on a runway. Each mission can last for hundreds of days, even years. It's involved in advancing technologies for America's future in space. The X-37B is a pathfinder, paving the way for next-generation space operations. It has broken records for long-duration spaceflight by a reusable vehicle. Its impact will be loud and clear in the technologies of tomorrow. Getting into space is hard, but what about slowing down once you're out there? You could fire your engines, but that uses precious fuel. This is where aerobraking comes into play. Aerobraking is using a planet's atmosphere as a brake. Imagine a spacecraft approaching Mars. Instead of firing its thrusters, it makes dips into the upper layers of the Martian atmosphere. Each dip creates drag, reducing the spacecraft's speed without using large amounts of propellant. The benefits of aerobraking are enormous. By reducing the amount of fuel needed, spacecraft can be launched on smaller, less expensive rockets. This makes missions more cost-effective and scientifically productive. Aerobraking has been successfully used on multiple NASA missions. It has saved significant amounts of fuel, extending mission lifetimes and enabling more science. Aerobraking requires precise navigation and a deep understanding of atmospheric dynamics. It's a cosmic ballet of gravity and atmosphere. SpaceX Dragon, a new breed of space taxi, revolutionizing how we think about space travel. Dragon has fundamentally altered the landscape of space access, making it more feasible and frequent. It comes in two versions, one for cargo and another, Crew Dragon, specifically designed for astronauts, ensuring their safety and comfort. The Dragon spacecraft is a testament to the power of reusability, a concept that is transforming the economics of space travel. Both versions are designed to be recovered and reflown, significantly reducing the cost of accessing space and making missions more sustainable. Dragon typically launches atop SpaceX's Falcon 9 rocket, whose first stage also lands itself for reuse, showcasing advanced engineering. Dragon's primary role has been to service the International Space Station, delivering essential supplies and crew. The Crew Dragon has restored America's ability to launch its own astronauts to the ISS, a significant milestone in space exploration. Beyond the ISS, Dragon represents a broader shift towards commercial entities playing a major role in space, opening new frontiers. SpaceX has shown that private companies can develop and operate reliable, cutting-edge space transportation systems, pushing the boundaries of what's possible. This opens up possibilities for future commercial space stations, space tourism, and even ambitious missions to the Moon and Mars, expanding human presence in space. Dragon is a symbol of a new, more accessible space age, where the stars are within reach for more than just government agencies. Coming home runway versus splashdown. Getting to space is only half the journey. The X-37B and SpaceX Dragon have different methods for returning to Earth. The X-37B performs a runway landing. It glides through the air like an airplane and touches down on a designated runway. This offers a gentle return, important for sensitive experiments or payloads. The spacecraft can be quickly accessed on the ground for retrieval. SpaceX Dragon uses splashdown. After re-entry, the Dragon capsule descends into the ocean. Recovery ships then retrieve the capsule and its occupants or cargo. Splashdowns have a long heritage dating back to the Mercury, Gemini, and Apollo programs. Both runway landings and splashdowns are effective methods for bringing spacecraft home. The key is always the safe return. Smart landings and cosmic breaks. The genius of innovation. The journey into space and back is fraught with challenges. Innovations like aerobraking, autonomous landing systems, and reusable components are essential. They represent the human genius for problem solving. Consider aerobraking again. By using a planet's atmosphere to slow down, we save enormous amounts of fuel. It means we can design longer missions, carry more scientific instruments, or reach destinations that would be impossible with purely propulsive braking. Autonomous landing systems allow spacecraft to navigate complex re-entry and landing sequences without direct human piloting. These innovations reduce risk and cost, two of the biggest barriers to more extensive space exploration. Reusable rockets and spacecraft drastically cut the price of admission to space. It's this relentless drive to innovate that truly defines the spirit of space exploration. Echoes of the shuttle and dreams of tomorrow, modern marvels like the X-37B and SpaceX Dragon build upon the legacy of past space missions, most notably the Space Shuttle. These advanced spacecraft are the result of decades of innovation and learning. The shuttle program was a groundbreaking endeavor. It revolutionized our approach to space travel and set the stage for future missions. It taught us about reusable spacecraft and the challenges of runway landings from space. The shuttle's ability to return to Earth and be used again was a monumental achievement. The X-37B is a direct technological descendant of the shuttle. Its design and mission capabilities are a testament to the shuttle's enduring influence. The lessons learned from the space shuttle have influenced today's spacecraft. Engineers and scientists continue to build on the knowledge gained from those early missions. Similarly, the Apollo program's experience with splashdowns informs Dragon's recovery method. The transition from ocean landings to runway landings marks significant progress. Looking to the future, these technologies are paving the way for routine and more accessible space travel. The dream of making space travel as common as air travel is becoming a reality. Imagine a future where trips to orbit are common, where scientists can easily conduct experiments in microgravity. This future is closer than we think, thanks to ongoing advancements. Innovations like the X-37B's long-duration missions and Dragon's cost-effective transport are crucial stepping stones. These missions demonstrate the potential for extended stays in space. They are making space less of an exotic frontier and more of an extension of our human domain. The boundary between Earth and space is becoming increasingly blurred. The journey is far from over, but with each successful mission, we get closer to a future where humanity is truly a multi-planetary species. The dream of reaching Mars and beyond is within our grasp. The best is yet to come. As we continue to innovate and explore, the possibilities for the future of space travel are limitless.